So my name is Mohammed Azhar Uddin. I joined UW River Falls last fall, and I'm a DIH funded faculty there. And um, as I started over there, uh, I was kind of struggling where to start my research, and then Chuck helped a lot to give me some idea and what could be a good starting point. And in the meantime, um in October, I came across a report that was published by the DACAP, where they did a survey of Wisconsin dairy farms, and I kind of glimpsed into the report and then got interested, and then that's where I got the idea of this study. In this research, I'm kind of trying to understand if we can predict the dairy farms exit using our most recent data that we are seeing from the Wisconsin. And is there any person in our audience that who had a farm, dairy farm, or has a dairy farm? So you have, and do you have that farm yet, or you kind of? Okay, you don't. So can you tell us like when did you exit it and why? And I can give you the mic if you like. I'd like to hear from you because that could be.
We got out of milking cows. Okay. We got out of milking cows in 2018. We left as we transitioned the farm from one generation to the next. My sister-in-law who took over milking the cows, her and her husband actually moved up to northern Wisconsin, took the cows with them up there, and now we just raise custom heifers and run beef.
Great. That's kind of uh, an anecdote, but can kind of supplement what we are going to see here. So the farm exit is not something new. It's been happening since last 20, 30 years. And the researchers are asking this question since then. So one question is what motivated me to ask this same question again. So one reason is that the farm exit 20 years ago could not be the same, may not follow the same reason today because time has changed, industry has changed, technology has changed, right? So we might find new answer for these new types exits. And the method that we are using to predict those exits earlier, that can have some drawbacks. And we now have these days more advanced method called machine learning techniques. So I'm kind of intrigued to apply those newer techniques to see if that can tell us anything new. So having said that, let's discuss like what I'm going to talk about in this session. So I'll try to give you a bit overview about the Wisconsin dairy industry and how the farm exit trend looks like. And just to give you a note about the exit, the data I'm using that kind of talks about the exit intention. Those are not actual exits. So in the survey, they ask one question: are your farms will be a dairy farm in next 5 years? If the answer is no, then I'm considering this as an exit or exit intention. And then, as I said, this question has been asked for long, so we know, so we have some already known knowledge from the literature that what are the main causes or what could be the reasons for those exits. I'll overview that, and then when I discuss my studies findings, that can actually help you to compare if we are learning anything new over there. And then I'll not juggle too much about a lot about those methods, but I'll try to tell a story from these research findings. And uh, let us have a look of the Wisconsin dairy industry in terms of number of farms and cows. So this graph shows that in 2023 we have about 6,000. We had about 6,000 dairy farms in Wisconsin. However, in 2024, new data shows that we lost about 203 farms. That means, on an average, every month, 17 farms exited the industry. And in terms of numbers of cows, we have about 1.27 million dairy cows in Wisconsin, and that's from 2023. However, in 2024, we only lost about 5,000 dairy cows in Wisconsin. That means, on an average, we did not lose that much of cow compared to the number of dairy farms that we lost. And if we compare the average number of cows in USA, you'll see that California usually have very large farms in terms of number of cows. Wisconsin in 2023 had 215 cows on an average in a farm. And in 2024, because we did not lose that much cows, on an average, the number of cows has increased in our farms. And still, these are kind of family farm size. That's why in Wisconsin, we say that these are mostly run by the family farms. And that's kind of true. The survey data also shows that around 99% of farm identifies them as family farm. And I tried to kind of plot the exit data for last 14 or 15 years. If we look back at 2010, we had around 12,400 dairy farms. In 2024, the number is 5,700 around. And as you can see that the curve is kind of bending a bit. Probably we are getting slower rate of exit. Those who are probably inefficient or don't see enough potential in the business, they have already exited the business, and now we are kind of seeing a bit of slowing down in the rate. So I'll talk about a bit about what we have learned from our past studies. And those studies kind of explored different characteristics of the firm. One of the characteristics would be the demographic and operator characteristics. And the major one always popped up as a reason for exit is the age of the operator. And then age of the operation also plays a bigger role for farm exit. And one of the studies find that if the operator has a college degree, they will most likely exit. That means if the education level is higher, on an average, the farm exit is more prominent. And then farm structure and production process, these type of data is also being analyzed to understand the farm exit. And as you can tell, if the herd size is smaller, the exit rate is high. And this is also this can also be said that when the herd size is small, it is easier to exit for the farms if there is not enough potential. And two other variables that also been explored or analyzed for the farm exit. One of the variable is average meal productivity, and the other one is technical efficiency. Both are kind of proxy to each other, and it shows that if the productivity is high or the farm is more technically efficient, they are less likelihood of the farm to exit. And then financial factors are also being analyzed. Returns to the variable cost. That means if you cannot retain your day-to-day expenses to run the farm, or return on equity, if these are low, there is high risk for the farm to exit. And then long-term debt. This is pretty interesting. More debt reduces the farm exit probability. That means there are more investment going on in this farm. So why it is important to predict farms? First of all, it gives us more data-driven insights about policy that if we know about what are causing those farms exits, then policymakers might have identified some important factors that they can actually improve or come up with interventions to prevent those exits. And these could have greater implications for our rural economy too. So I use machine learning techniques over the traditional logistic model because it gives us some better predictability. For instance, one of the study reported that it was really hard for their model to predict exits rather than those farms who want to continue. That means given the data and logistic model, we can easily predict those who are going to stay, but it's really hard to predict those who are going to exit. So I mainly used 4 models. I'm running out of time, so I'll try to go to the results more quickly. The way this model works, we split our data into 2 parts. Using one part of the bigger chunk data that we train our model. That means we train the model to learn how the exits looks like. And then we use rest of the data to test that if the model can actually predict those exits and what is the success rate of doing that. So these data came from, as I told you, from DayCap survey, and I'm really grateful to them that they shared this data for this study. And in this study, the hard definition includes only the cows that are being milled. And I use about 96 covariates to explain or predict those exits. I have 2 minutes. I'll go to the results pretty quickly. So in our data set, overall exit rate was 19%. That means about 81% farm will continue in next 5 years, but 19% said that they are going to exit. And the exit rate is pretty high in conventional dairy farming rather than organic. And this is also kind of matches the previous findings. And our data came from 4 regions of Wisconsin, and Southeast region have slightly higher exit tendency compared to the other regions. And as our earlier study said, that if the herd size is small, the exit could be higher. The general statistics show that those farms who have smaller herd size, they have higher exit rate. And age of the farmer also impacts the exit rate. If the farmer is old, then the exit rate is much more higher. And I'd like to talk about this a bit quickly. Aging facilities of those dairy farms are one of the major challenges for them to continue the milking. The second highest challenges was finding labor, and third one was day-to-day expenses like those variable costs. And those machine learning models that I use, I evaluated their performance, and based on that, the extreme gradient boosting performed much better. But I'll leave this technical discussion for later. If you have any questions, I can come back to that. So model performance-wise, as I said, extreme gradient boosting performed much better. Here is the kind of final bottom line that what I find in terms of what are the most important predictors of this study. And I help you to understand this graph a bit. If the bar is much more longer, that means this variable has more. Can I get 2 minutes more? Okay, no question then. So, if the bar is more longer, that means it has more impact on predicting either. If this is blue, that means it helped to predict farm's continuation. And if the bar is red color, that means it helped to predict farm's exit. So you can see that, I asked the model to give me top 20 predictors. And you can see that out of 20, only 8 helped us to predict the exit compared to the stay. And what is the most important predictor that the model found is identifying successor. if you cannot identify the successor, there is more likelihood that this farm is going to exit in next 5 years. And then age of the facility is the second, I'd say the first major cause of farm exit. And the second one is the age of the farmer. If the farmer is 65 or more years old, they're more likelihood to exit. And previous studies more talk about age of the farmers, but our model shows that aging facilities where investments are required, if they do not make those investments, these farms are more likely to exit. And then inavailability of labor, that is also kind of tracked by our model. And then age is one of the things. So if the farmer is 50 or plus age, there is more likely to exit of that farm. And then herd size is kind of also one of the major predictor of farms exit. One of the interesting results here I am seeing that I don't understand, maybe you have better idea, or you can share that if you have some insights. If the farm's feeds are coming 100% from the farm activity, they're more likely to exit. That means if they're producing their own feed 100% in their farms, they will more likely to exit. And the region of southeast of Wisconsin, they are more likely to exit. And I learned from another person that why this matters, because there is urban sprawl on that side from Chicago and Milwaukee probably. That's why land are more valued and farms see more benefit by selling those land, exit, and go to somewhere else. I'll stop here today. Thank you very much for this opportunity. And if you have any questions, maybe I'll be there. You can ask me later. Thank you very much.